Hello everyone, today we will discuss about principle of optimality or dynamic programming. So today we will discuss about dynamic programming. It is mainly used for solving the optimization problem. So what is optimization problem? Optimization problem is used for solving minimum result or maximum result. So in this dynamic programming part, we will discuss some part. These are introduction to dynamic programming, giving difference between dynamic programming and greedy method, and also showing the difference between memorization and tabular method by taking an example with details. So at first we discuss about the difference between greedy method and dynamic programming. So greedy method used for solving optimization problem, like as dynamic programming also used for solving optimization problem. Greedy algorithm take decision in one time. Dynamic programming take decision at every stage. In a greedy algorithm, we make whatever choice seems best at the moment, and then solve the sub problems arising after the choice is made. In dynamic programming part, in dynamic programming we mainly choose at each step, but the choice may be depends on the solution to sub problems. um, Next point is more dynamic greedy method is more efficient as compared to dynamic programming, and dynamic programming is less efficient as compared to greedy method. The example of the greedy method is fractional knapsack, and 0 1 knapsack is the example for dynamic programming. So dynamic programming means we will try to find out all possible solution and then pick up the best solution or optimal solution. This approach is little different and little time consuming compared to greedy method. For any problem there may be many solutions which are feasible, then we will try out all through solution and then pick up the best one. Mainly dynamic programming solved by using recursive formulas. So mostly dynamic programming solved by iteration rather than recursion. So that means for solving the dynamic programming we use recursive formulas, but the way is iterative or iterative method rather than recursive, means recursive method. So dynamic programming follow the principle of optimality. Principle of optimality means the decision to get the optimal solution. So showing the memorization and tabular method, we take an example which is suitable for the dynamic programming, memorization or tabulator which is suitable to showing this. So we can take an example. So example is on Fibonacci series. So Fibonacci series is starting with 0 and every term is obtained by adding previous two term. Like as 0, then it's 1. So next term will be, third term will be 0 plus 1 is 1. So fourth term will be 1 plus 1 is equal to 2. So like that it will come. So total, if we taken an algorithm in recursive way, it's get integer fib, integer n terms, up to n terms, int fib, int n, and if n less than equal to 1 then return n, if not then return fib n minus 2 plus fib n minus 1, means it's can done by recursive way. So like as recursion, so total time taken is fib n is equal to, for 0 is come if n is equal to 0, 1 is come if n is equal to 1, and fib n minus 2 plus fib n minus 1 if n greater than 0. So now we showing how the function or algo work to find out any term. So like fib 5 means Fibonacci of 5 means fifth term I want to find out. So now check 5 is less than equal to 1. No. If so, it's return n only, otherwise called to function, add the result and return the result. So it's look like as this type. So this algo is followed to draw a tree, for example of fib 5. So fib 5 is divided into two parts, fib 3 and fib 4, and fib 3 is divided into two parts, fib 1 and fib 2. Then fib 2 is divided into fib 0, fib 1, and fib 4 is divided into fib 2, fib 3, and fib 2 is divided into fib 0, fib 1, and fib 3 also divided into fib 1 and fib 2, and fib 2 is always divided into fib 0 and fib 1. So for fib 0 and fib 1 part, no recursive call, direct return result is returned. So here the tree end or function terminate. So in the tree, last leaf part is fib 0 and fib 1, all part is fib 0 and fib 1. So here we have no here the tree is terminated. So no recursive call is happened in this part. So the result come by adding last part, we get upper part of this two part. Next, if you add continuously, you get result. So if you calculate fib 0 and fib 1, add them, then you get fib 2, then fib 1 and fib 2, if you can add, then you get fib 3, then fib 3 and fib 4 you can add, you get fib 5. So like as the result will be come. Like in this tree we add fib 0 and fib 1, we get fib 2, and then if you add fib 1 and fib 2, we get fib 3, and again we add fib 3 and fib 4, we get fib 5. Like in this way we get result. So this will be the tracing tree of that particular algo or recursive function. So now for finding fib 5, it's taken total 15 calls. So if I consider all the calls and find out the time complexity of this tree, then if I see from this particular algo or function here, return fib n minus 2 plus fib n minus 1. So if I assume to get conclusion, fib n minus 2 is fib n minus 1, so I can write I can assume that fib n minus 2 is fib n minus 1. So it's look like fib n minus 1 plus fib n minus 1 means, so total time taken is Tn is equal to 2t n minus 1 plus 1. And by master theorem for decreasing function, if you take that, is means is b go 2 to the power n, because fib n minus 2 is replaced by fib n minus 1, so it's can less from that part, so it belongs in upper bound of function. So the time taken by the particular algo or recursive function is big O of 2 to the power n. So how recurrence relation is done, it's already you know. So if I consider this Fibonacci series, it's take too much time or exponential time, so here any possibility to reduce the exponential time. So now you look at the tree, that is, you at first you already know the tree. So here fib 1 so many time it's called, and fib 2 also so many time it's called. So here for reducing the time we can avoid the calling part. If it is same, means same things cannot be called again and again. And if we take a global array for that purpose, so it looks like that. So it looks like that. So this is in the global array, and this is the tree, and this tree belongs from this algo. So here initially global array is filled by -1. Initially there have no value, so we can fill by -1 because nothing is none. Then trace the tree once again. So for first function fib 5 is -1. We do not, means its first time count we do not know, so then we call fib 3 is also -1, we do not know, so then we call fib 1 is -1, we do not know, but here the tree is terminated. So from the algo condition fib 1 is 1, so in array 1 position you put 1 replacing with -1, that is shown in figure like that. This is shown in figure. Here we can put 1 because fib 5 we don't know, fib 3 we don't know, fib 2, fib 1 we don't know, but here the loop is terminated, here that loop is end, the tree is end. So here this is this part is known as, so from this condition you can check, and there this is now fib1 is 1, so this is completed. So next we have to check fib2. Fib2 is -1, we do not know, so then we call fib0 is -1, we do not know, but here also the tree is terminated, and in this part fib0 also be terminated. So here fib0, from this condition we can check, and then the result will become fib0 is equal to 0. So the -1 can be replaced as 0, that is shown in figure like that, that is shown in figure like that. So fib0 and fib1 you can complete it. Next part is, so next we have to check fib1, but this function is already checked, so do not check again, because fib1 already checked. So here we cannot check again, because fib1 already checked. We can avoid this, because we can avoid again and again type same things we can avoid. But this function is already checked, so do not check again. So it looks like that. So we already know fib0 is 0 and fib1 is 1 from this array, and for getting the result of fib2, if we add them then get the result. So result will be add fib0 0 and fib1 1, then 0 plus 1 is equal to 1. So the result of the fib2 or value of the fib2 is 1, that is shown in figure. So fib1 you know and fib0 you know, and here fib1 already done, so here not count, but here fib1 also value you know, that is 1. So 0 plus 1 is equal to 1. So the fib2 value will become by fib0, add fib0 and fib1, that is shown in figure. So next, now we can now we already know the fib1 and fib2, then add these two results and get fib3 also, that is 1 plus 1 is equal to 2. So fib3 is now 2. So here fib3 is now 2, because fib1 and fib2 you know that. So fib3 will come 2, that is shown in figure. So now we come to root node again. So we come the root node again, fib5 is -1, then we go for the right side, we check fib4, here it is also -1, then we go for fib2, but it's already checked. When we come to fib3 to fib5 root node, then again we check by -1, it's don't show, then fib4 it's also don't show, but fib2 is, when we come in this point fib2 in right hand side fib2 there, because in left hand side already fib2 is checked. So here we can avoid the fib2 part, and also check, so avoid it, and its leaf node also you can avoid fib2 and fib2's leaf node also, that is fib0 and fib1. And also when we will come and fib3, so fib4 value is, so now fib4 value is 1 plus 2 is equal to 3. So fib4 is 3. Now we again check from fib5 from the root node, add fib3 value, that is 2, and fib4 value, that is 3. So and add them and get the result fib5. So finally you can get the root node result, that is showing in diagram, that is showing in diagram. So the total process is 6 calls can done. So in this process, in this total process, the 6 call can be done. So total you know that tree will be, at first we know the tree will be between 15 calls will be there, but here we can reduce it's on 6 calls. So when I have give fib n, so it's making n plus 1 calls, so it's you can say order of n or theta of n. So here we can reduce the value, reduce the value, because previously we can see this, see that the here value or time is taken by order of n square, or order of 2 to the power n, and then it is come in order of n. So we can reduce this part. So here this is the memoization method, which is showing in details. Here we can avoid repeating calls by taking global array, and in algo part we can make fib n minus 2 into fib n minus 1 for creating situation like that, and we can apply the memoization method, and the memoization method can reduce the time 2 to the power n to n also. And memoization followed top down approach also, because here always we can start from when the leaf node is completed, always we can start from the root node. So it is a top down approach, because in this example we always calculate from fib 5, that is root node or starting node of this example. Now in the same example we implement the tabular method. Tabular method mainly used for solving dynamic programming problem like memoization method. So here also we can take global array, and here we can take also the total time relation, and that is 0. If it is 0, then if n is equal to 0, then it is 0. If n is equal to 1, that is 1. If n greater than 1, then it is fib n minus 2 plus fib n minus 1. So Fibonacci series nth term, but in algo we used loop. In memoization method we cannot use any loop. Here only recursive way we can solve this part. But here in Fibonacci series nth term, algo will be taken, and here we can algo will be here in this part, algo we used loop. So here we can see that in this algo int fib int n. So here if you take any value in int n part, so then we check it is less than equal to 1. If it is so then it's return n. If it is not, then otherwise its part came into f0 is equal to 0, it's already predefined, and f1 is equal to 1, it also be predefined for. So the loop will be continued from 2 to n. So then if I check fib 5 from this algo, then if n less than equal to 1, then it's return result, but otherwise it fill the array f0 is equal to 0 and f1 is equal to 1. So it looks like the array, if we fill, you already know, because it is assigned or predefined, f0 is equal to 0 and f1 is equal to 1. So you can add this, put this array into the table format. So next consideration, the loop we start from f2 onwards. So 2 to n it's go. So and in example n is 5, so it's check 2 to 5 also. So getting any a5 term, it's adds previous one. It is the rules of Fibonacci series. So for f2 is f0 plus f1, so it becomes 0 plus 1 is equal to 1, so f2 value is now 1. And again for I plus plus condition, f1 plus f2, so it becomes 1 plus 1 2, so f3 is coming, is f3 result is 2, and again f2 plus f3 is so it's become 1 plus 2 is equal to 3, so f4 is 3, and again f3 plus f4, so it's become 2 plus 3 is equal to 5, so f5 value is 5. So final result will be come. So now array or table it's become like that, f0 1 1 2 3 5. So here for dynamic programming we mainly followed iterative or tabular approach, because its calculation done from smallest value onwards, because here we can start from 0 part or 0 from 0 part array, but in memoization part we can start from 1 onwards. So here we calculate in tabular approach from smallest value onwards. So this mainly follow the bottom up approach. Here we can start from smallest one to highest one. So it is follow bottom up approach. So note that any of two method you can use for dynamic programming. Thank you everyone.